Okay, computing is an internet-based technology. Without internet, we cannot access any kind of service-based applications. Okay, so that's why you need to use cloud computing concept in order to store huge volume of data. So the backbone for cloud computing is data center and virtualization. What is meant by data center? Data center is a collection of high integrated servers at one place, each company having their own data center, and virtualization is the ability to perform multiple tasks in a single system with the help of virtualization technologies like VMware, Hypervisor, Zen Virtual. So if you press capital A on keyboard, system cannot understand. Internally, it converts into ASCII format. ASCII stands for American Standard Code for Information Interchange. For every character, for every letter on the keyboard, we have ASCII values. If you press capital A, the binary, the the decimal number of capital A is ASCII value is 65, and if you divide it by 2, we are getting binary equivalent number is 10001. That means computer understands only ones and zeros. So 1 bit is 0 or 1, 4 bits is 1 nibble, 8 bits equal to 1 byte. After that word, 1024 bytes is equal to 1 kilobyte. Megabyte, gigabyte, terabytes, petabytes, hexabytes, octabytes, zettabytes, yottabytes, brontobytes, and geobyte. After that, geobytes infinity. This is the way we are measuring the data in computers, servers, and data center. So same thing we can incorporate in mathematical representation. Kilobyte is 10 power 3, megabyte is 10 power 6, gigabyte is 10 power 9, terabyte is 10 power 12, 10 power 15 petabytes, hexabyte is 10 power 18, zettabyte is 10 power 21, yottabyte is 10 power 23, brontobyte is 10 power 27, geobyte is 10 power 30. This is the way we are measuring the data in computers, servers, and data center. So welcome to today's topic, virtual private cloud. Before going to virtual private cloud, I need to explain the fundamentals within 5 to 10 minutes. Then we will move to these contents. Today I am demonstrate introduction to virtual private cloud. What is the exact definition of virtual private cloud? What are the overview and understanding of what a virtual private cloud, and what are the key benefits why we are using privacy, scalability, security, and the cost effectiveness, and we are solving the real world applications like use cases in education, research, and industry, and what is architecture and the components of virtual private cloud. What are the key components like subnets, gateways, routing tables, and elastic internet protocols. Then what is meant by network isolation? How a VPC ensures secure and isolated environments in public cloud. So VPC diagram walkthrough. I'm going to demonstrate the diagram with each and every. Then practical setting up a virtual private cloud hands-on, how to create environment setup using Amazon Web Services, Google Cloud, or Azure for creating a virtual private cloud, configure subnets and gateways, and practical task 1, how do we can create a new virtual private cloud, allocate internet protocol ranges and set up subnets, and a practical 2, set up a virtual machine instance within the VPC. virtual private cloud in isolated environment, and we are creating with the high security in a public cloud, connected to a public subnet with an elastic internet protocol, then followed by the securing a virtual private cloud. How do we provide security for my virtual private cloud, which is created isolated in a public cloud environment? Then security groups and firewalls. How to we can set inbound and outbound rules, restricting unauthorized access. Practical task 3, we are creating security groups to allow deny specific traffic, test the security settings with different access rules, then followed by the access control, role-based access control, that is RBAC implementation. All these practicals I have implemented through Python in AWS environment, or Google Platform Cloud, or IBM Bluemix Platform Cloud. Then fifth topic today is networking in a virtual private cloud applications. So by using NAT, network address translation, use of NAT gateways for internet access. Practical 4, set up a NAT gateway for private subnet instances. Peering and a virtual private network, understanding VPC peering and secure VPN connectivity. And the practical 5, peer 2 VPs, how do we can create and enable communication between two virtual private clouds, that is called intra cloud. And the last topic today's my session, monitoring and managing virtual private cloud. So here I am using practical 6, cloud monitoring tools using Amazon Web Services CloudWatch, Azure Monitor, or Google Stack Driver for tracking, and best practices for virtual private cloud, cost optimization, efficient subnet allocation, and proper access policies. And last practical session on enable monitoring for virtual private cloud resources and analyze logs. Who entered into my virtual private cloud, when he entered, when he logged out, all those logs we are maintaining in this monitoring application. Before going to our virtual private cloud, what is cloud and what is 543 formula everybody knows. So according to NIST standards, National Institute of Science and Technology USA, John McCarthy and his group, they have given the beautiful definition. Cloud computing is a model for enabling ubiquitous, convenient, on-demand network access. Means everywhere, anywhere, 24 by 7, we are accessing through internet to a shared pool of configurable computing resources such as servers, computers, networks, storage, applications, and various kinds of services that can be rapidly provisioned and released with minimal management effort or service provider interaction. The entire subject, cloud computing information, is available in this beautiful definition. And it is a internet based computing. Actually, cloud computing is derived from a network diagram like transmission control protocol or IP internet protocol, TCP/IP, and cloud is an internet-based development for applications and services. Cloud computing is a multi-tenant architecture, means multiple users connecting to the cloud and accessing the information, like tenants. From Google Cloud, everybody is accessing through mobile, through computer, through laptop, through any electronic gadget we are connecting and we are accessing the services. It is called multi-tenant architecture. It is a 543 formula, 5 characteristics, 4 infrastructure models, and 3 major services. I'll give you short form so that you can remember very easily. 5 characteristics are OBR square M. O stands for on-demand computing. B stands for broad network access. R stands for resource pooling. One more R stands for rapid elasticity, and M stands for measured service. 4 infrastructure models like types of clouds, P square HC. Public cloud, private cloud, hybrid cloud, community cloud. And 3 major services like SPI, software as a service, platform as a service, and infrastructure as a service. Cloud computing is a form of distributed computing. The heart and backbone for cloud computing is data center and virtualization. And these are the OBR square M. So everybody knows, no need to explain. On-demand self-service means 24 by 7 accessing, pay and use. And resource pooling, all the services at one place. Broad network access, 24 by 7, anywhere, any place you can access with any device. Rapid elasticity means number of users are increasing, automatically your data size center also increases, your server capacity also increases. Measured services, how much consumption you are performing, that much amount you need to pay. That's why cloud computing is a pay and use service. 3 major services like software as a service, platform as a service, and the infrastructure as a service. So these 5 characteristics I have explained, and these are the SPI, 4 types of clouds, and public cloud everybody can access, private cloud only operated by organization of in the organization people. They are operating solely for an organization, only employees. Community people are sharing their information. Hybrid cloud, 50% public, 50% private. So, so these are the popular clouds under 4 types of clouds, and the differences between public and private cloud everybody knows. Hosted at a service provider site. Here hosted on a enterprise or a service provider site. Supports one customer. Here supports multiple customers. Okay, and there are various security is very less in public cloud and security is very high in private cloud. There are 3 important service SPI. No need to explain. Everybody knows. The popular cloud under software as a service cloud, Salesforce.com, and platform as a service cloud. The number one cloud is you can consider IBM Bluemix and Google Cloud. Infrastructure as a service, Amazon Web Services EC2 and S3. Amazon company is the first movers towards cloud computing. They are the stepping stone towards cloud computing. That is Amazon, Jeff Bezos. And these are the delivery models. Also call it as services. Major services, SaaS, PaaS, IaaS. These are the popular clouds, platforms. And architecture, cloud computing architecture is nothing but structure which comprises software and hardware components and connections among them. So the major components consist of cloud consumer, cloud provider, cloud auditor, cloud carrier, cloud broker. So this is the beautiful diagram for cloud computing architecture and all types of services. These are the major components: cloud consumer, cloud auditor, auditing security audit, privacy impact audit, performance audit, and a cloud provider service orchestration. Service layer consists of SaaS, PaaS, IaaS. Cloud service management consists of all these: provisioning, ability, business support, etc. And a cloud broker is managing intermediation and service aggregation, service arbitrage. So these are the five components. And what is meant by virtualization? Virtualization is the ability to perform multiple tasks in a single system with help of virtualization technologies to perform a multiple task with help of virtualization technologies. Popular virtualization technologies like VMware, Hypervisor, Zen, Virtualiron. And these are the popular virtualization technologies. So we are performing various tasks like memory virtualization, storage virtualization, network presentation, application, hardware, software, server, desktop, whatnot. Even our Gmail is a best example for a consumer of cloud computing. Whenever you are logging into Gmail, you are accessing the service 24 by 7. That comes under application as a service. So Gmail is a best consumer of cloud computing. And all these, see the popular virtualization technologies like VMware, Hypervisor, Virtualiron, Zen, and major characteristics like performance, scalability. Scalability is nothing but we day by day users are increasing automatically. The data center also increases in terms of computing power, in terms of infrastructure, in terms of server capacity, automatically increases. Availability 24 by 7, manageability, security, and these are the various applications we are performing with the help of virtual private cloud or public cloud, private cloud, hybrid, and community clouds. So the popular virtualization technology VMware. VMware is a company, and the name of software also VMware. And we can perform various kinds of VMware virtualizations, server virtualizations, and we are performing various types of virtualizations with help of VMware. And then the major concern still R&D is ongoing. Maximum 95% security issues they solved in their organizations, in especially in cloud security. It is a major concern. And the goal of cloud security is privacy, authenticity, integrity, and confidentiality. And the scenario of security in cloud, we have customer data, customer code, and provider premises. So the first antivirus virus of cloud computing is Pandas, is developed by Panda company. Security cost money, but it also cost in time, convenience, capabilities. Bruce Snyder, he has explained a beautiful definition about security. And so there are, according to Gartner survey, there are various challenges still playing a vital role like security. Still, it is R&D is ongoing. So many papers are coming in cloud security, performance, availability, integration, customization. That's why we are concentrating on various research challenges. And these are the cloud security requirements, cloud security aspects. And these are the three types of cloud security like host security, data security, network security. We have various types of softwares, security issues. Algorithms are available. And these are the three types of data security, network security, and host security. So what is meant by, so before going to virtual private cloud, how do you can define a VPC? It is a high security cloud and isolated environment we are creating within a public cloud. See, I have already explained what is meant by public cloud. Everybody can access that cloud. Okay. And what is meant by public private cloud? Only employees of that organization people are accessing that cloud. Then what is meant by virtual private cloud? Virtual private cloud is a secure cloud and isolated environment we are creating within a public cloud. It allowing users to manage and control resources like storage and data and services as in a private cloud environment. That's why it is called a virtual private cloud. It offers key benefits like we are increasing privacy and scalability, robust security, and cost efficiency by leveraging shared infrastructure. With help of VPC, no need to purchase separate server once again in your organization. So if you use any virtualization technologies, you can use virtual technology software like VMware hypervisor. You can create n number of virtual machines, and you can provide security for that cloud, and that also you need to purchase from organization like Amazon. In public cloud itself, you can create your own virtual private cloud, and you can provide security, and it is in isolated environment. uh, as a user admin, we are allowing users to manage all the privileges and control resources as a private cloud. And what are the applications we are going to solve with help of VPC? VPCs are widely used in education sector, especially whenever results are releasing that day, the servers are becoming very busy. That time, these VPC clouds are playing a vital role, and we are developing applications in education, research, and industries for hosting applications, managing data, and enabling secure collaboration, etc. So this is the scenario like in virtual private cloud. We have uh, public cloud environment through internet. See here, public users are accessing the information. Company A people are accessing the information. Company B people are also accessing the information. But the company A and the company B, they can interact through intranet, and we are creating a private segment of public cloud like storage. We are creating one separate VPC and computing service, application service, platform as a service. So as a VPC client or admin can have a privileges and can have a control permissions to access the storage, data, everything with the help of this VPN service cloud. That's why virtual private cloud is a secure cloud and isolated cloud environment within a public cloud infrastructure. That's why it is called a virtual private cloud. So best examples for virtual private clouds like Amazon VPC. See, Amazon having EC2 and S3 very big clouds like Amazon Web Services, providing isolated cloud resources within a public cloud. So, if any organization taking a rental basis from Amazon, so all the departments are accessing their own cloud information, results accessing, and notice board kinds of information. Everything we are accessing. So whenever you are a cloud administrator, you are creating a VPC cloud environment within the public cloud so that you can have your own privileges and have security and privacy and in isolated environment. So there you can see the high security comparatively public and public cloud environment. Even Google Cloud VPC also you can create a scalable and a secure global virtual network for Google Cloud services, same as Azure Virtual Network VNet, Microsoft VPC you can create. It is equivalent for securely hosting resources in Azure. These are the three best examples of virtual private clouds. And this is the scenario I have explained already. VPC is an isolated cloud, secure cloud, network environment within a public cloud. It's offering dedicated resources for enhanced privacy, security, and control. You can see in public cloud through internet, network of networks, public users are available, company A and company B. So through this VPC, we can have a platform services, application services, virtual private network client, computing services, storage services through VPN. That means you are creating virtual private network, okay, virtual private network cloud, which is isolated and high security network environment within a public cloud. So that we are providing high privacy, security, and all the privileges of uh, the clients who belongs to that particular VPC cloud. So this VPC creates within a shared public cloud infrastructure with isolated resources, while a private cloud is a dedicated. Suppose that VPC for only CSE department people are accessing and publishing their results. It is a standalone environment exclusively used by a single organization, single department. So the difference between VPC and private cloud. So private cloud operated by one organization, one administrator, and is private cloud only employees are accessing that private cloud, and this VPC operates, virtual private cloud operates within a shared public cloud infrastructure with isolated resources, okay, and which is having high security and having the privileges and monitoring control access, etc. Then what is meant by architecture and the components of virtual private cloud? So architecture is nothing but structure which comprises the software and hardware components and connections among them. And this VPC having subnets, gateways, routing tables, and elastic internet protocols, IPs, enabling efficient resource management. Why we are using this VPC? For efficient storage utilization, for efficient service kinds of sharing management, everything we are performing with efficient manner. Then in this network isolation, VPC provides secure and isolated environments by using firewalls and access controls and private networks. So through VPC diagram, I am going to demonstrate how many components are typically set up of this virtual private cloud, including architecture components and their interactions for secure cloud operations. If you see this VPC architecture diagram, it enables secure and isolated cloud environments through subnets, through gateways, through routing tables, and firewalls. If you see, we have a public cloud environment. So there I am creating VPN through internet. Internet is nothing but network of networks. I have public users Company A accessing information from public cloud through internet. Company B people are also accessing the information. Now see what are the privileges for VPN customers. A private segment of the public cloud. So it is a VPN client. It is performing storage services, computing services, and application services and platform services. So this is the VP virtual private cloud architecture. So through DALI AI automation tool, I have created a diagram. So this VPC diagram explains the number of components and their interactions for secure cloud operations, internet gateways, subnet, and virtual private cloud, and say NPS, routing tables, security, routing gateways. So this is one type of VPC architecture. This VPC architecture in Amazon Web Services, how it look like? How do you can create a VPC environment in a cloud environment? Okay, so if you see the VPC subnet availability zone in Elastic Cloud Computing, it is a big cloud in Amazon Web Services, and VPC subnet EC2 through router and the internet gateway, internet, remote management and administration. We are creating virtual private cloud, and we are having and we have this virtual private cloud having privileges, having high security, etc. Then I'm going to demonstrate a practical session. How do we can set up virtual private cloud? So for environment setup, we are configuring a virtual private cloud using Amazon Web Services. That is a number one cloud for infrastructure as a service cloud, and Google Cloud and Azure by setting up subnets and gateways for efficient network segmentation. The practical one, what I am going to create a new virtual private cloud with allocated IP ranges and define subnets for public and private access. So first, let me check the first practical. How do we can create a virtual private cloud with allocated IP ranges? Okay, so create your own private network to secure your servers by isolating them within a virtual private cloud for enhanced privacy and control. See here, we have a public cloud environment. There we are creating number of VPs, number of virtual machines, and through internet, and through gateways, through subnets, through routing protocols. Okay, so now the first application I am going to demonstrate, write a Python program is to create a virtual private cloud, that is VPC, with both public and private subnets, configure a domain name service support, and set up isolated network environments in AWS using Python and the Boto3 library. Boto3 is a library in in Python programming. With the help of Boto3, we can access any kind of virtual private cloud information, cloud service based information in Amazon Web Services. So here, how do we can create a VPC ID, and how do we can create public subnet created with ID, and how do we can create a private subnet created with ID. So I am going to demonstrate this one first application. See here, Just you can install Python software. Once you have licensed version in Amazon Web Services, you can check whether you have installed Python or not. So what is the version? 3.13.1. Okay. So Python can be executed in two ways. One is IDLE and one more is a scripting way. So this is IDLE, Integration Development Learning Environment. Here also you can execute and you can see this is IDLE. Now I'm moving to scripting way. There I'm writing my own program. So notepad space VPC, virtual private cloud 1.py. So the first program, see here, write a Python program is to create a virtual private cloud VPC with both public and private subnets, configure DNS support, and set up isolated network environments in Amazon Web Services using Python and the Boto3 library. This Boto3 library is very popular, especially for cloud computing environment. How do we can configure in service, private subnets. So I haven't installed this Boto3. Now I'm going to install. So pip install Boto3. This is the library. This is the way we can install. I'm importing Boto3. Then what I'm doing, initialize the Boto3 library client for EC2. And EC2, I'm allocating with Boto3 with client EC2, region name, and suppose US or India. Step one, what I'm doing, create a new VPC, virtual private cloud. Then what I'm doing, I'm setting up the response, VPC response with EC2 cloud, create VPC, so and so IP address I'm creating. Then VPC ID, I'm assigning with the VPC response, that is VPC ID. Then I'm printing that virtual private cloud ID. Then I'm enabling domain name service support and host name. That also I'm printing that enable DNS support and enable host name support. Then step 2, what I'm doing, create a public subnet. And so I'm creating a one class for that one. Then that VPC ID assigning, that IP address I'm assigning to that one, availability zone. So what I have created, that one I'm assigning. Then I'm printing that public subnet create with ID also I'm printing here. Then step 3, create a private subnet. So private subnet response I'm assigning. Then that same ID, whatever I have used previous, same thing I am assigning to VPC ID. And for that, see here I am assigning for private public cloud 1, here 2.0 for private cloud, then availability zone same. Then I am printing the private subnet create with ID. Just I am setting up the environment and I am creating virtual private cloud with both public and private subnets. Just I'm configuring DNS. See now, if you see here, until unless you have Amazon Web Service license, you can execute. Otherwise, it will throw error. See, I'm executing. So 1 second. I'm using environment. Uh, 1 second. So Google Colab I'm using, so that you can execute in Google Colab environment. We are executing this one. See here. So I'm executing this one. This is the program. Control E. You can execute first program. Google Colab. You can see here, here I am executing this one. See, now my program is executing and creating. See here, write a Python program is to create a virtual private cloud with both public and private subnets. See, my program is running. So until unless you have Amazon Web Services document, see here, see now, see first ID I have created and private, see here, virtual private cloud and see here, one second. So this is the output, first program. So this is the output, the first program. So we have created a VPC created with ID, public subnet created with ID, and a new VPC has been successfully created. A public subnet has been created and associated with the VPC. A private subnet has also been created with VPC. This is the first program. Then the second programs, if you can see in Google Colab, it is executed with the 3 IDs, and it is asking there is no Amazon Web Services even in this Google Colab also. It is throwing error until unless we have that environment we can execute. We'll try for next program. So next concept, second program. Write a Python program is to deploy an EC2 virtual machine within a virtual private cloud, configure it with a public subnet, set up a security group for SSH and HTTP access, and associate the instance with an elastic IP for external connectivity. So for this program also we are expecting, we are creating and deploying EC2 virtual machine, VPC cloud. We are once we are executing this program, so it displays the output like a security group created with ID and inbound rules added, security group, EC2 instance launched with ID, elastic IP allocated, elastic IP also associated with the instance. See, this program we will try. So second program, notepad space VPC2. So this is the second program. Write a Python program is to deploy an EC2 virtual machine within a virtual private cloud, configure it with a public subnet, set up a security group for SSH and HTTP access, and associate the instance with an elastic IP for external connectivity. So here also we are importing a Boto3 library. The first step, we are initializing Boto3 client for EC2. And second step, we are replacing these with your VPC subnet and key pair details. Then first we are assigning all these group names, my security group, and key name is your key pair name, VPC ID, public subnet ID. Then step 1, what we are doing, create a security group for the instance, and add inbound. In step 2, what we are doing, add inbound rule to allow security, SSH and HTTP access. For that one, we are defining and we are assigning a group ID and IP permissions and IP ranges. And IP ranges, we are declaring the port number 80 from port 22. Then we are printing inbound rules added to security group. Then step 2, launch and EC2 instance in the public subnet. These all are Amazon Web Services. If you are having a licensed version, from there you can deploy this program and you can create this Elastic Cloud Environment PPC. Then allocate an Elastic IP address in step 3. In step 4, associate the Elastic IP with the instance. And finally, we are printing the Elastic IP associated with the instance. See what I am doing. This program I am going to execute in Google Colab. This is the Google Colab environment I am trying to execute. See now. So write a Python program is to deploy EC2 virtual machine. See, it is throwing error because it is saying that. So unless we have a group, Amazon Web Services environment, then only we can execute. What is the output we are getting with this program? Security group created with ID, inbound rules added to security group, EC2 instance launched with ID, Elastic IP allocated, Elastic IP associated with the instance. So next concept is securing a virtual private cloud. We are providing security for the VPC with the groups and firewalls. We are defining the inbound and outbound rules to control traffic and restrict unauthorized access effectively. So for this concept, we are developing a program called Create and Configure Security Groups for specific traffic types and test access using different security settings. So access control, we are implementing role-based access control, that is RBAC to manage permissions and secure access effectively. So program 3, see what is private cloud storage, why we are creating this private cloud storage. So create your own private network to secure your servers by isolating them within a virtual private cloud for enhanced privacy and security and control. For that purpose, we are creating this security groups and firewalls. We are assigning the security. So for that one, we are writing a program in Amazon Web Services. Once you have that license, Amazon Web Services Cloud, then you can use this program and directly you can deploy and get the EC2 cloud environment. Like write a Python program is to create and configure a security group in a specified VPC with inbound rules for SSH and HTTP access, and to validate its configuration using Amazon Web Services EC2 services through the Boto 3 library. So what I am doing, I am importing Boto 3. From Boto core, we are importing non-credentials errors like AWS credential setup. Once you have licensed version in Amazon Web Services, we have access key and a secret key you can assign, and we are expecting output from this one. We are providing security for the group. We are creating with ID. Inbound rules added for SSH for port number 22 and HTTP 80. Security group details like security group, group name, my security group, group ID, etc. So this is the third program. So VPC 3. See, write a Python, third program. Write a Python program is to create and configure a security group in a specified VPC with inbound rules for SSH and HTTP access, and to validate its configuration using Amazon Web Services EC2 services through the Boto 3 library. So pip install Boto 3. So here we are creating AWS credential setup. We are initializing the EC2 client and create a security group. Then add inbound rules for allowing SSH and HTTP access. Then see here, test cases setting by describing the security group, whether it is working properly or not. We are checking with that test cases, and we are executing this program. See here, we will go for Amazon. See here, in Google Colab, I'm trying to execute this program. See, write a Python program. See, this program is executed. So it is saying that when calling the create security group operation, Amazon Web Services was not able to validate the provide access credentials. This program is successfully executed. Write a Python program is to create and configure security group in a specified virtual private cloud, but you need to have Amazon Web Services was not able to validate the provided access credentials. It's okay. Once you have Amazon Web Services cloud environment in your organization, I'm going to provide all these programs so that you can execute in your AWS cloud. Then the fifth concept is networking in VPC practical applications. So by using network address translation, we are enabling instances in private subnets to access the internet securely via NAT gateways. So here, two applications we are performing, like configure a NAT gateway in a public subnet and update private subnet routes for internet access. And one more application, peering and VPN, establish secure connections between virtual private clouds using peering and VPN for seamless data transfer. So practical 5, implement VPC peering to enable communication between two VPs, virtual private clouds, and verify connectivity. So everybody knows what is meant by NAT. NAT gateways are used in virtual private clouds to provide internet access to instances in private subnets. So it gives us private instances can connect to the internet for updates or any communication without being exposed directly to external traffic. So what is meant by peering and VPN? VPC peering allows private communication between two VPs in the same or different Amazon Web Services accounts. VPN provides a secure connection between a on-premises network and a VPC, enabling hybrid cloud setups. For that one, we are going to demonstrate one application. So this is the network address translation. So how we are using network address translation gateway for creating VPC peering and VPNs to manage and optimize network traffic effectively within the cloud environment. If you see here, so through network address translation, we are performing various applications, various services we are performing. So write a Python program is to set up a NAT gateway in a public subnet, allocating an elastic IP for it and configure the route table of a private subnet to route internet traffic through the NAT gateway for secure and managed internet access. For that one, what I am going to do, so we are creating IP, elastic IP, from EC2 cloud in AWS only. So finally, we are getting output like elastic IP allocated for the NAT gateway, network address translation. NAT gateway created and associated with the public subnet, a route added in the private subnets, route table to direct internet traffic via the NAT gateways. See, let me execute this program. Notepad space notepad space VPC 4, fourth program. So write a Python program is to set up a network address translation gateway in a public subnet, allocate an elastic IP for and configure the route table of private subnet to route internet traffic through the NAT gateway for secure and managed internet access. For that one, we are importing same Boto3 library, and but here we are using AWS credential setup. So replace with your once you have licensed from IBM, I mean Amazon Web Services, you will get access key, secret key, region, so that you can perform this application and replace these with your VPC and subnet IDs. And step one, what we are doing, we are allocating elastic IP for NAT gateway. And step two, create NAT gateway in public subnet. And step 3, update route table for private subnet to use NAT gateway. And finally, we are printing those values. If it is working properly or not, if it is showing any errors, we are checking with this NAT gateway address. So I'm going to execute this program also. See here. So I'm using Google Colab and pasting my code. So I'm running this program. See here, write a Python program is to set up a NAT gateway in public subnet. See, my program is executed, but it is saying that authentication failure. You need to have, when calling the allocate address, AWS is not able to validate the provided access credentials. The program is running unless you have Amazon Web Services environment with license version, you can execute and you can set up NAT gateway in public subnet and allocate elastic IP address. And you can route table of information, you can perform it. Next concept is fifth program. Write a Python program is to establish a VPC peering connection between two virtual private clouds and configure their route tables to enable seamless communication between the virtual private clouds. So here also we are creating a peering. That means peers, one end to another end, one cloud to another cloud, one server to another server. How do we can create a establish connection between two VPs, that is intra-cloud, virtual private cloud, and how do we can configure their route tables to enable seamless communication between the virtual private cloud. So this program also, we need to have a AWS account so that this program, whenever you execute successfully, it will display VPC peering connection between first it will display the VPC connection created ID, then VPC peering means one end connection PCX will be accepted, then route table will be created, then VPC peering setup complete successfully. You can see notepad space virtual private cloud VPC 5 last but one program. I'm closing the practical session. Next program, write a Python program is to establish VPC peering connection between two virtual private clouds and configure their route tables to enable seamless communication between the VPs. So here also you need to have Amazon Web Services access key, secret key, region, replace with all those IDs. Step 1, we are creating VPC peering connection one end to another end. Then step 2, we are accept the VPC peering connection from the second VPC. Then we are displaying whether that VPC peering setup completed successfully or not. See, now this program I'm going to execute in Google Colab. So I'm using Google Colab as a platform where you can run your Python programs with utilizing high computing configuration. See, this program is executed and but it is throwing same error. Amazon Web Services was not able to validate the provided access credentials. So until unless we have Amazon Web Services license, then you can deploy all these programs, practicals you can execute. So next, last concept, monitoring and managing VPC. What is meant by monitoring and managing VPC virtual private cloud? With the help of various tools like Amazon CloudWatch, utilize the AWS CloudWatch, Azure Monitor, or Google Stack Driver to track VPC, virtual private cloud performance and activity. So best practices, we are implementing cost optimization strategies and allocate subnets efficiently and enforce proper access control policies. The last program, write a Python program to create and enable monitoring for VPC resources, configure logging and analyze logs for insights and troubleshooting. So this is the VPC traffic mirroring, means copying one server to another server data to monitor traffic entering, leaving a virtual private cloud and intra VPC traffic. How do we can monitor the data? How much data we are transferring from one system to another system, one server to another server, one VPC to another VPC. And with the help of CloudWatch, we can track the performance. We are analyzing logs, how many users are entered, how much data is transferred, and ensure optimal security and operational efficiency in the virtual private cloud environment. For that one, we are writing a program. Last program, write a Python program is to enable monitoring for virtual private cloud resources by creating a CloudWatch log group, enabling VPC flow logs to capture traffic details and retrieving sample log events for analysis and troubleshooting. So for this one also we are importing Boto3 library, and once setup was created, we can monitor once VPC setup and resources are created. With help of CloudWatch, we can set up AWS client, then run the Python program, expected outputs. You can see the how many users are connected, how much data is transferred, how much data is migrating, mirroring from one VPC to another VPC. All those things we can see through this program. Notepad space virtual private cloud VPC 6, same program. Write a Python program, same thing. And the first step, we are utilizing CloudWatch, creating log group for VPC flow logs. Step 2, we are enable VPC flow logs, and we are checking sample log events, how many events created, how many messages sent, everything. So now I am executing this program. Go to Google Colab and run this program. See, write a Python program. It is running right now. So same thing. We need, see, whenever this program is calling the create log groups, the security token including the request is in. So we need to have AWS credentials for this one. Then it will execute it. So then what are the applications of virtual private cloud? We can secure web hosting applications, data backup and disaster recovery purpose. We are using virtual private cloud, big data analytics and processing, e-commerce applications like Amazon, Flipkart, IoT and edge computing, enterprise application hosting, development and testing environments, machine learning and deep learning AI workloads, remote desktop services and virtualization, healthcare data storage and analysis. And what are the advantages of virtual private cloud? We have enhanced security, scalability, cost effectiveness, customizable networking, high availability, and improved performance, seamless integration, data privacy, resource isolation, ease of management, and these are the challenges. Still, if participants are interested to do research in this virtual private cloud, still there are problems like ensuring robust data security and privacy. That is a one research paper title. Managing and optimizing resource scalability, achieving seamless multi-cloud integration, addressing network latency and performance issues, implementing efficient cost management strategies, designing effective disaster recovery and fault tolerance mechanism, overcoming compliance and regulatory challenges, enhancing inter-VPC communication and peering, addressing complexities in VPC automation and orchestration, and maintaining real-time monitoring and proactive threat detection. With this one, I am closing my session. And if you are having any doubts, you can ask any doubts. Hello, madam.
Yes, sir. Yes, sir. I request participants, if you're having any queries, you can ask now.
Yeah, these are my previous programs. And any doubts, please. Yeah. So how many of you attended my previous sessions? Please, um, any doubts, please ask me. And if you have a mobile or a laptop, you can check my YouTube channel. There are various cloud applications, and I have deployed with previous organization. I have that credentials. Now it is not working. In this YouTube channel, please subscribe my channel. It is not for money. Okay, type my name, Dr. Asadi, Asadi Srinivasulu. Please type all of you 1 minute and click my channel name, Dr. Asadi Srinivasulu. You will find 333 videos are there. See here. Please take 1 minute time, subscribe my channel and listen my videos. If you are having any doubts, you can contact through mobile or WhatsApp or email. I'm sharing my details also. So these are previous videos. So only 5 members subscribed right now. Remaining, how many participants are there total, madam?
Sir, 147 are there, sir.
Yeah. Please, my dear friends, any doubts, please ask me. This is my address. This is my mobile number. If you are having any doubts, you can, I'm sharing this PPT to your coordinator so that you can contact me for any collaboration research work, for any proposal writing, publication writing, For any help, I am going to help you. And this is my channel. You type my name, you will get my channel and subscribe it and write one comment. Any comments from participants? Any feedback from the participants? If you are not asking any doubt, at least you can give my feedback about virtual private cloud. Any doubt?
Sir, I think we can wind the session, sir.
Yes, madam. Thank you.
Okay, it's my honor and privilege to extend my heartfelt gratitude for our today's speaker for accepting our invitation and being a part of this FDP in spite of such busy schedule. On behalf of management of Aditya College of Engineering, Dr. RMD Shafi sir, coordinator of this FDP, and on my own behalf, I wholeheartedly thank Dr. A. Srinivasulu sir for handling this session in a clear and productive way. Thank you, sir.
Thank you, madam. Yeah.
I thank all the learned participants for joining this session to enrich their knowledge in cloud computing. Thank you, one and all. Again, we'll join in 2 minutes. The link is shared in the group. Thank you all.